Welcome to the Deep Dive, the show where we take a mountain of information and distill it down into the most important, insightful nuggets just for you. Have you ever been using an app, maybe scrolling through social media or shopping online, and you type something in search or click a filter and it just hangs just for a second?
Oh yeah, that little
Yeah,
pause,
but-
super frustrating.
Or maybe it just feels slow, sluggish, like it's constantly trying to catch up with every tiny thing you do, every single letter you type. It drives you crazy, doesn't it?
It really does. We all want software that just feels, well, reactive, intuitive, snappy. Like it knows what you want before you even finish
Yeah.
clicking.
Exactly. That feeling, that magical responsiveness, and that desire for truly fluid, interactive apps isn't just something users want. It's a big engineering challenge, right?
Absolutely. A core challenge. And it's precisely right at the heart of what we're going to unpack today.
Spot on. Today, we're doing a really crucial deep dive into reactive programming with RxJS and signals in Angular. We've got a serious stack of sources here, everything from foundational stuff, research papers, to like real-world code examples and developer
A
notes.
proper mountain of info.
Definitely. And our mission, and yours, really, for the next, say, 20 or 30 minutes, is to pull out the most crucial, the most game-changing bits from all of this material.
And what you'll get from this, hopefully, is a really clear picture of the principles that make modern Angular apps feel so responsive and interactive. We're going to, pull back the curtain on how RxJS and signals actually work.
Yeah, what they do.
Exactly. What are their roles? When should you use one versus the other? Because that's key. And crucially, how they work together, how they combine to create these really powerful, performant results.
And we're not just talking theory here. We're going to walk you through real-world examples. Things like building those slick, efficient search boxes we mentioned, the ones that don't hammer your server constantly.
Or handling things like global hotkeys, making your app feel really intuitive.
Exactly. So settle in, maybe grab a coffee, because this is going to be, pretty illuminating, I think. Let's really get into it.
All right, let's start right at the beginning, the foundation. Before we even talk RxJS or signals specifically, we need to tackle that basic question.
Oh,
What is reactive programming?
right, the core idea.
At its simplest, it's about writing code that essentially observes events and then reacts to notifications about those events. Now, when we say event, that could be anything that happens over time.
Like what?
Well, a user clicking a button, that's an event. Data changing inside your app, that's an event, a key press, data coming over the network, all events. And similarly, state is just the current data values defining your app's condition, like how many items are in your cart or the text in a search box.
Okay, so it's like setting up listeners. Your code listens for specific things happening, user actions, data changes, and then acts on them.
Precisely. And the why behind this is huge. It makes applications fundamentally more responsive, more interactive. Instead of your code constantly having to check, has anything changed? Has anything changed? It just gets notified.
Which makes it feel much more dynamic, more alive, right?
Yeah.
Not sluggish or static. It leads to that smoother user experience we all crave.
Exactly. And the goal isn't just responsiveness itself, it's efficiency. Your code only gets told about the actions or the data changes it actually cares about. It's not wasting time checking everything.
It's targeted. It waits for the right signal, the right event, and then it reacts. That targeted approach must be way better for performance.
Massively better. It saves resources and users aren't left waiting. It's just smarter.
Okay, so that distinction, not constantly checking, but intelligently reacting, leads us straight to one of the biggest names in this space, RxJS. If you've done much with JavaScript, especially Angular, you've definitely run into it.
Oh, for sure. RxJS reactive extensions for JavaScript, it's a huge, really powerful library specifically for reactive programming. It's kind of a cornerstone in the Angular world.
So what's its main job? Its primary role?
Its main thing is observing events and data streams over time. Think about things that happen continuously or, asynchronously at unpredictable moments.
Like typing into a search bar.
Exactly. Keyboard events as you type. Or routing events when you navigate pages. Changes in form inputs. Or maybe the most common one, getting data back from an HTTP request to a server. RxJS gives you a consistent, powerful way to watch and react to all these dynamic, time-based things.
It treats everything like a stream of events.
Pretty much, yeah. And the core way you interact with these streams is by subscribing.
Subscribing. Okay, like on social media.
That's actually a fantastic analogy our sources use. Think about it. You subscribe to someone's feed. When they post something new, the app doesn't make you keep refreshing, right?
Oh, it just tells me, sends a notification.
Exactly. It emits a notification,
That
and then you react. Maybe you like it, share it, whatever.
I see. So with RxJS, my code subscribes to a source, like mouse clicks or that HTTP response.
Right. And when something happens at the source, an event occurs, data arrives, your subscription gets a notification. That notification triggers your code to react in whatever way you've defined.
That seems really powerful, a consistent way to handle anything happening over time.
It is, and the fundamental building block in RxJS that makes this possible is called an observable. Think of the observable as the thing doing the watching for new posts, new events, new data, and then emitting those notifications when something happens. It's the watcher.
Okay, observable, the watcher. Got it. So that's RxJS, mature, deeply integrated. But then there's the newer kid on the block in Angular. Signals.
Signals. Another really crucial piece, specifically designed and optimized for Angular. A signal basically is a data value plus a built-in way to notify others when it changes.
A value and a notification.
Exactly. And they are the recommended, most performant way now to define and manage your data, your state, within Angular components and services. They let Angular observe your data very efficiently and tell you instantly when it changes.
And the big win here, especially for performance, is change detection. Right? That's what I keep hearing.
Absolutely. That's perhaps the key benefit. Angular's change detection used to be powerful, but a bit mysterious sometimes. With signals, Angular knows exactly what data changed, so it knows exactly what part of the template needs updating.
So it doesn't have to re-render as much stuff?
Precisely. It can be much more deliberate, much more targeted. It limits re-rendering, which means better UI performance, less wasted work, a smoother feel. It's a genuine game changer for rendering efficiency.
That sounds huge. And they're widely available now.
Yep, since Angular 16. So most teams using Angular can start using them right now, even if they're not on the absolute latest version. They're practical and impactful today.
Okay, so we have RxJS for event streams over time and signals for managing state changes right now. The big question then is, how do they work together? When do you pick one over the other? Where's the overlap and where are they distinct?
That's the critical piece to understand. Their roles are distinct, but often complementary. Signals really shine when you need to watch and react to changes in state, like individual variable values changing.
Like a counter or a checkbox state.
Exactly. Or a selected item's ID, a Boolean flag. If you have a piece of data that changes and you want to react instantly, maybe update the UI based on it or do some calculation that depends directly on it, signals are perfect. Simple, synchronous, very performant for reactive state.
Right, like that e-commerce example. If I change the quantity of an item, I want the total price to update immediately. A signal for quantity, a signal for price, and maybe a computed signal for the total. Instant reaction.
Perfect example. It's all about that direct, synchronous reaction to data changes. Now, RxJS, on the other hand, is the master when you're dealing with streams of events or asynchronous data arriving over time, often unpredictably.
Like those keyboard inputs again.
Or
clicks.
Exactly. Or the data eventually coming back from an HTTP request that might take a few seconds. When those things happen, RxJS gives you this incredibly rich toolkit to perform a whole series of operations on that data as it flows through. Control over time, sequence, transformation. That's RxJS territory.
So they're not really competing. They work together.
Absolutely. Especially when dealing with data, particularly asynchronous data, they are better together. Think of RxJS as handling the async plumbing, making HTTP requests, handling retries or errors, maybe merging data from a couple of different API calls.
Right, getting the data in.
Exactly. Once RxJS has done its job, fetched the data, maybe transformed it a bit, signals take over beautifully. They're ideal for managing that retrieved data, calculating related values from it, like that total price, and then binding it efficiently in your template so Angular updates the UI smartly. It's a really nice handover.
That makes sense. RxJS for the journey, signals for the destination state.
That's a good way to put it.
Which brings us to a really important point. Why is RxJS still so core to Angular, even with signals? You hear about signals, and you might think, okay, is RxJS fading away? But that's not the case at all, is it?
Not even slightly. It's a common misconception. RxJS is still absolutely vital, indispensable, really, because it's so deeply woven into Angular's core features. It's not just an extra library you choose, it's fundamental to how parts of Angular work under the hood. You're often using it without even realizing it.
Like with routing. navigating between pages.
Exactly. Angular's router relies heavily on observables. It uses them to watch for changes in route parameters, query params, route data, navigation events, everything. That's what lets your components react smoothly as the user navigates, fetching new data based on the URL without needing a full-page reload. It's seamless because of RxJS.
In forms, too, right? Reactive forms.
Definitely. Reactive forms are built on observables. You type in a field, check a box, whatever observables are firing off those changes. This enables all the cool stuff like real-time validation, dynamic forms, all powered by RxJS streams.
And the HTTP client making calls to the backend.
Yep. When you use HTTP client.get to fetch, say, a list of products, it doesn't just give you the data back immediately. It gives you an observable.
Ah, right.
That observable then emits the data when the server responds. This lets you easily chain operations, transform the data, handle errors gracefully, retry the request if it fails, all using RxJS operators before the data even hits your component.
So it's baked right in. Routing, forms, HTTP.
It's deeply integrated. That's why Angular still installs RxJS by default. It's essential for handling the async, event-driven nature of web apps. Many of Angular's best features just wouldn't work the same way without it.
Beyond that deep integration, RxJS also just makes handling general events way cleaner, doesn't it? Like those keyboard presses we keep mentioning. Handling things that happen unpredictably over time can get messy otherwise.
It really can. Let's walk through that keyboard example again because it shows the elegance. Say you want to react whenever a specific key is pressed anywhere in the app. The keyboard is the source. RxJS lets you create an observable to watch that source.
Okay, so the observable watches the keyboard.
Right. And your component subscribes to say, tell me when a key is pressed. Now here's the cool part. User presses R, the observable sees it, but it doesn't just blindly pass the raw event. It can use operators.
Operators, like tools to modify the stream.
Exactly. Maybe an operator converts the key to uppercase. Maybe another filters out everything except R. It processes the event before emitting. Then it sends a notification with the process value of R to your component.
And the component then reacts to that specific R, moves a game piece, whatever.
Precisely. Observe, operate, emit, react. It's a clean pipeline, way better than nested callbacks. And crucially, remember memory leaks. When the component is done, maybe it's navigated away from, you must unsubscribe.
Right, stop listening. Otherwise, the observable keeps firing into nowhere, leaking memory.
Exactly. Forgetting to unsubscribe is a classic bug. It degrades performance over time. Cleanup is vital.
Okay, speaking of operators, you said they let you process the data. That sounds like where a lot of the power lies. Data composition, transformation.
Oh, absolutely. This is where RxJS really shines for complex tasks. Think of it like setting up an assembly line, a pipeline for your data. Each operator is a station on that line doing a specific job.
Modifying the data as it flows through.
Exactly. You define a sequence of operations, maybe filter out bad data, transform formats, combine pieces from different streams. RxJS has over 100 operators for this. Modify, filter, combine, handle errors. Incredibly powerful stuff without writing tons of messy loops or if statements.
Yeah, you mentioned error handling, like with those network requests.
Yeah, it's great for that. An HTTP call fails. Use an operator like catcher to handle it cleanly. Maybe retry the request a few times automatically.
Right.
Or just tap into the error to log it without crashing everything. It makes your app much more resilient.
And for complex data, like combining stuff from different places.
Operators are lifesavers there. Imagine getting user data, then needing to fetch their posts, and then maybe their recent comments. Operators let you orchestrate all that, merge the data, reshape it perfectly for your UI. It avoids so much complex manual code, it's declarative and much easier to maintain.
Okay, so we get the why and the what of RxJS. Let's really nail down the core building blocks. Observable, observer, subscription. You hear these terms all the time.
Right. And that data stream idea can be a bit misleading. It's often not a continuous flow like a river. It's more like discrete items on a conveyor belt. That analogy really helps.
The conveyor belt. I like that. Okay, break it down.
So the observable is the conveyor belt itself. It's the mechanism designed to move items, let's say apples, through processes. But crucially, the belt doesn't move, doesn't do anything until you turn it on.
And turning it on is.
That's the subscription. Subscribing is like pressing the start button on the conveyor. Without a subscription, the observable is just sitting there, potential pathway, but no apples are moving.
Got it. Observable, conveyor belt blueprint. Subscription, turning it on. So who gets the apples?
That's the observer. The observer is waiting at the end of the line, ready to receive each apple as it comes off the belt. The observer is set up with callback functions passed into the subscribe method to handle different notifications.
Okay, what kinds of notifications?
3 main types. First, next. This function runs for every single item emitted. An apple arrives, next gets called, and you do something with that apple, clean it, label it, whatever. This is where your main processing logic goes.
Process each apple as it arrives. Makes sense. What else?
Second, error. If something breaks the machine jams, an error occurs in the stream. The error notification fires. The conveyor usually stops, and you handle the problem. Essential for robustness.
Okay, handle breakdowns. And the third.
Third is complete. When the last apple has gone through and there are no more coming, you get the complete notification. It signals the end of the stream. Work is done. Time to power down.
It's next for items. Error for problems. Complete for the end. Clear. And back to the subscription, why is unsubscribing so critical again?
Because just like you'd shut down the conveyor when you leave the factory, you must unsubscribe when your component doesn't need the data anymore. If you don't, the observable keeps running, keeps trying to send apples notifications, even if no one's there to receive them.
Leading to those memory leaks. Got it. It keeps working unnecessarily.
Exactly. It wastes resources and can cause subtle bugs. So always clean up your subscriptions. It's vital for application health.
And that $ convention. Apples instead of apples.
Yeah, that's just a common visual cue. Seeing the DAW reminds you, this is an observable, not a plain value. I can't just read it directly. I need to subscribe to get values out of it. Helps avoid mistakes.
Okay. Observable, observer, subscription, conveyor belts, apples, $. I think we've got the foundations. Now let's see this in action. Practical applications. How do we use this stuff to build cool features, like those global hotkeys?
Perfect example. Global hotkeys, like air for help, escape to close something, need to work anywhere, anytime, right? Not just when an input is focused. This kind of global asynchronous event listening is prime territory for RxJS.
Now, how would we set that up?
Okay, first, you'd have your help message content. Then, crucially, an Angular signal, let's call it show help, a Boolean, to track if the help dialog is visible or not.
Signal for the state. Check.
Then, the core part. An observable to listen for keyboard events across the whole page. For this, we use an RxJS creation function called fromEvent.
FromEvent sounds specific.
It is perfect for DOM events. You tell it what to listen to, in this case, the entire document object and which event key down. Boom, you have an observable that emits every time any key is pressed anywhere.
Okay, but that's every key. We only want add or escape.
Exactly. So we build an operator pipeline using pipe. First, operator.map. The raw keydown event has tons of info. Map lets us transform it, pull out just the event.keystring so we get add, escape, etc. Much simpler.
Nice, just the key itself. What's next in the pipe?
Maybe tap for debugging. Tap lets you peek inside the stream. You can console.log the key value at this point to see what's flowing through without actually changing the value. Super handy for troubleshooting.
Like looking at the apples in the belt without taking them off.
Exactly. Then, the really important one, filter. We only care about Figurla. And escape. Filter lets only those specific keys pass through, ignoring everything else. Hugely efficient. It stops unwanted events right there.
Filters out the noise, so now only Kafel Sakame gets through.
Right. And finally, another tap. This time, the tap does the actual work. Based on the key that got through the filter, or escape, it sets our show help signal to true or false.
So the final tap triggers the UI change by updating the signal.
Precisely. The whole thing is one clean declarative pipeline. From event, map pal, maybe tap debug.pap of React.
Very elegant. But clean up. Unsubscribing. That from event keeps listening globally, right?
Critically important here. If the component using this hotkey gets destroyed, that from event observable is still listening, still emitting. Classic memory leak scenario. The old way was unsubscribe in Injung on destroy.
Which works, but you have to remember it.
Exactly. Easy to forget. But modern Angular 16+ gives us take until destroyed. It's an Angular operator. You import it, add it as the very last operator in your pipeline.
Take until destroyed at the end.
Yep. And it automatically unsubscribes when the component or its context is destroyed. No manual unsubscribe needed. Much less boilerplate, much safer.
That sounds brilliant. Any catches?
Two main things. It needs what's called an injection context, usually meaning you define it in a constructor using inject or as a class property where Angular knows its lifecycle.
Yeah.
And second, it really should be the last operator. Anything after it won't get automatically unsubscribed.
Got it. Last operator needs injection context. Huge improvement, though. Okay, that pattern makes sense for events. What about data? Efficient data retrieval. You mentioned the new resource API and Rx resource.
Yes. This is a massive improvement area. Before Angular 19, getting data with HTTP client and putting it into a signal involved quite a bit of manual work.
How so?
You'd call HTTP client.get, which gives you an observable. Then you had to manually .subscribe to actually make the request. When the data came back in the subscription, you had to manually .set it into your signal. And you have to remember to unsubscribe later to avoid leaks. Lots of steps, lots of repetition. Felt fraught with peril, as one source put it.
Yeah, sounds like boilerplate city, easy to mess up. So how does RxResource change that?
It's part of the new Experimental Resource API, and RxResource specifically integrates with observables. It simplifies things dramatically. First, it gets the data directly into a signal for no manual setting.
Nice.
Second, it automatically handles the subscribe and unsubscribe. No more manual cleanup needed for the fetch itself. Huge win for preventing leaks.
Automatic subscribe. Wow.
And third, it gives you built-in iLoading and error signals. Makes showing loading spinners or error messages in your template super easy.
Okay, that sounds much, much better. How do you use it? How do you call RxResource?
You call RxResource and pass it a config object. The main property is stream. You set stream to an arrow function that returns your observable, typically your HTTP client.get.
So stream this.http.get.
Exactly. RxResource takes that, subscribes to it, runs the request, gets the data, unsubscribes, and puts the data into its internal signal, which you access, all automatically.
Sweet. What about that initial undefined state while it's loading? Can you avoid that?
Yep. There's an optional default value property. You can set it to, say, an empty array if you're fetching a list. That way, your signal has a valid default value right from the start, avoiding undefined checks in your template.
Very useful. Now, you mentioned it can be reactive. The params property. That sounds powerful.
It's the magic ingredient. The params property makes RxResource reactive. You pass it one or more signals. If any of those signals change value, RxResource automatically reruns your stream function to fetch new data based on the new parameter values.
Whoa. So if I have a selected produced signal and I pass that to params,
Then every time selected produced changes, RxResource will automatically refetch the product details for that new ID. No manual triggering needed, it just reacts. The params values are also passed into your stream function so you can use them in your HTTP call, like putting the ID in the URL.
that is slick. Truly reactive data fetching. And since the stream returns an observable, can I still use RxJS operators inside that stream function? Like sort the data before it hits the signal?
Absolutely, and that's the beauty of the Rx and RxResource. Inside your stream function, before returning the HTTP client observable, you can pipe on any RxJS operators you need. Use map to sort the products, filter to remove some, merge map to flatten things, transform the data however you want before it gets set into the signal.
So you get the power of RxJS pipelines right there at the source, combined with the automatic signal management. Best of both worlds.
Precisely.
Okay, comparing then. RxResource versus HTTP client directly. RxResource is way less code, safer, easier. But what about HTTP resource, the other resource flavor?
HTTP resource is even simpler if all you have is a basic URL string. No complex observable needed, no post-processing, just HTTP resource, perfect for the simplest GET requests.
So use HTTP resource for simple URLs, RxResource, when you need an observable pipeline for transformation or complex sources.
Exactly. And you still need HTTP client directly if you can't use experimental APIs yet, or crucially for requests that change data post-POT delete. The resource API is mainly for reading data right now.
Makes sense. RxResource handles complex reads beautifully. But what if the reads get really complex, like fetch a product, see it has supplier IDs, then fetch all those suppliers individually? That sounds messy.
That's a classic composition problem, and yeah, it can get messy fast with nested calls. This is another area where RxJS, specifically a function called fork join, is incredibly helpful.
Fork join. Okay, what does that do?
Fork join takes multiple observables, like several HTTP client.get calls, one for each supplier ID, and runs them essentially in parallel. The magic is it waits for all of them to complete successfully, then emits a single result, an array containing the results from all the individual requests.
So you get all the supplier details back at once in one neat array, but only when they're all finished.
Exactly. If any single request fails, fork join typically errors out, which is usually what you want. You need all the suppliers or none. It prevents partial data issues.
Neat. How would you wire this up with RxResource?
Okay, workflow would be, first, create a computed signal to get the array of supplier IDs from your currently selected product signal. This makes the IDs reactive.
Reactive supplier IDs. Got it.
Then, in your RxResource config, the stream function will use fork join. Inside fork join, you'll take your supplier words array and use JavaScript's map to turn each ID into an HTTP client call for that specific supplier. This gives fork join an array of observables to manage.
So fork join gets an array of HTTP request observables and the params for RxResource.
You'd set the params property of RxResource to your supplier X computed signal. This is key. Now, if the supplier X signal changes, new product selected, RxResource reruns the stream. And here's a neat trick. RxResource is smart enough to not run the stream if the params are null or undefined, like if there are no supplier IDs.
Oh, nice. So it doesn't run fork join unnecessarily.
Right. If there are IDs, fork join runs, makes all the supplier requests, waits, collects the results into that single array of supplier objects, and emits it. RxResource then puts that final array into its signal.
Wow. So you end up with a signal holding an array of fully loaded supplier objects. Then you could just use another computed signal to display their names, maybe comma separated. That's incredibly clean compared to manual nesting.
It transforms a potentially nightmare scenario into a declarative, manageable flow. Think about the state management, error handling, and race conditions you avoid. Fork join handles the orchestration beautifully. That compositional power is a massive RxJS benefit.
Absolutely. Okay, one more big use case. Handling user input intelligently, like for search. We touched on this. Typing is messy, right? You don't want to hit the server on every single keystroke.
Definitely not. User input is rarely predictable. Firing HTTP requests constantly is inefficient. Bad for the server, bad for the user experience. Plus, you often need to clean up the input, lowercase it, trim spaces. RxJS is perfect for this.
And the key technique is debouncing.
Debouncing, exactly. It's about consolidating rapid-fire events into one. Imagine a 400 millisecond timer on your search input. User types A. Timer starts. Before 400 meters, they type P. Timer resets, then P. Timer resets again. Only when they pause for the full 400 meters does the final value app get processed.
It waits for a pause in typing. It's smart. Why RxJS for this, though? Can't signals do it?
Good question. Signals are synchronous. They react instantly to value changes. They don't inherently understand time or delays. Observables do. They're built for managing events over time, so debouncing, throttling, delays, that's core RxJS territory.
Okay, so you need RxJS for the time aspect. How's the flow work? We have the search text in a signal.
Right. First step, bridge from signal to observable. Angular provides toObservable. You take your search text signal and call toObservable, this.searchText, remembering injection context. Now you have an observable search text that emits whenever the signal changes.
The signal to observable, got it. Then pipe operators.
Exactly. First, pipe into debounce time, 400, or whatever delay you want. This handles the pause logic.
Consolidates rapid typing.
Then, immediately add distinct until changed. This is important. If the user types app, backspaces to app, then types P again, the value is still app. Distinct until change prevents emitting the same value twice in a row, saving another unnecessary operation.
Only emit if the value actually changed after debouncing.
Oh?
Smart. Okay, now we have a debounce distinct stream. But RxResource needs a signal for its params, right?
Correct. So we need to bridge back. Angular gives us to signal. You pipe the observable stream into signal. This converts the latest submission from the debounced observable back into a signal.
Observable back to signal. So the full flow is to observable debounce time, distinct until changed to signal.
Almost. What about transforming the input, like making it lowercase before sending it?
Ah, right. Where does that go?
You'd add a map operator before to signal. So to observable to bounce time, distinct until changed, map to signal. This cleans the input before it becomes the final signal value that triggers the resource fetch.
Okay, to observable, debounce, distinct, map for cleanup, then to signal. And that final signal feeds into RxResource's params.
Exactly. That whole pipeline dramatically cuts down network requests, ensures clean input, and gives a really smooth search experience. It perfectly blends RxJS's time-based event handling with Signal's state management.
Yeah, it's a powerful combination. Okay, we've covered a lot of ground. Let's zoom out the big picture. When do you really reach for RxJS, and when are signals the clear winner? What's the rule of thumb?
Summarizing RxJS strengths. Definitely for reacting to asynchronous event streams, DOM events, keyboard, mouse, network, anything happening over time. Essential for hotkeys, game interactions, media controls. Also required by core Angular features. Routing params, reactive forms, HTTP client for non-resource reads or mutable requests.
And its superpower is composing and transforming complex data, right? Merging sources, flattening structures, processing input streams with debouncing or filtering, basically managing async complexity.
Absolutely. But here's the crucial shift. where RxJS is no longer the best tool and signals are way better. Before signals, people used RxJS observables, often with subjects, just to react to simple state changes.
Like selecting an item and then needing to fetch related data based on that selection.
Exactly. That often led to more complex, intimidating RxJS code than necessary for simple state reactivity. It felt like overkill sometimes.
Yeah, bringing in observables just to watch a single variable change could feel heavy.
Precisely. The signal advantage here is huge. For reacting to those state changes, user selects a product ID. Now fetch details. Signals, especially with Rx resource or HTTP resource, are vastly simpler, more declarative, and need way less code. Define the ID signal, pass it to the resource's params, and it just works. No manual unsubscribe chains needed for basic state-driven fetching.
That clarity and reduction in boilerplate for state changes is massive. So, the mantra, the guiding principle.
It boils down to this. When working with state, a signal is great. For an event-driven stream, an observable is keen. It captures that core distinction pretty well. Use the right tool for the job.
State, signal is great. Event stream, observable is keen. I like it. What an amazing deep dive today. We've really unpacked reactive programming, RxJS, and signals in Angular. You should now have a much clearer picture of how these tools help build those super responsive, efficient apps we all love.
From handling tricky user events like hotkeys, to streamlining data fetching and composing complex info, to making search boxes smart, it's clear how RxJS and signals work together.
They really do. They make our code better and our user experiences way more delightful.
Definitely. It's all about designing systems that react intelligently to change instead of constantly checking. And it makes you wonder, as apps get more real-time and users expect instant everything, how far can reactive ideas go? Beyond just UI and data.
Like influencing back-end design, microservices.
Maybe how we handle real-time analytics or inter-service communication. Could reactive principles fundamentally change how we build distributed systems? It's a fascinating thought about where this paradigm might lead next.
A really thought-provoking question indeed. Something to mull over. And for you, listening, we really hope you'll take these ideas back to your own projects. Where are you fighting asynchronous complexity? Where could state management be simpler?
Think about how RxJS, for those event streams and data flows and signals for clean state reactivity, could solve your specific problems.
Make your code more elegant, your apps faster, and ultimately, make your users happier. We hope this deep dive has given you the insights and confidence to explore that. Thanks for tuning in to The Deep Dive.